Hello students. So in last lecture we have discussed about the SN1, SN2, E1 and E2. So we have discussed the substitution reaction and elimination reaction in the last lecture. Okay, now we are going to discuss the rearrangement reaction. Rearrangement reaction. So in case of the rearrangement reaction, there is a rearrangement of atom or group of atom within the molecule from one side to another side. Let me take one simple example. For example, we have this type of molecule. So this is the ortho position and this is the para position. So we can say that there is a rearrangement of the acyl group. Remember this one, COCH3 is known as acyl, or many times we use term acetyl, particularly CH3CO is known as acetyl group. In general case RCO, this is known as acyl group, right? So here acyl group is migrated from this position to ortho or para position. So here two product is possible. First one, here O is converted to OH, COCH3 transfer to ortho position, or the second possibility is here OH and this COCH3 group is transferred to para position. So there is a migration of atom or group of atom within the molecule. So there is a transformation, or we can say that rearrangement of particular atom or group of atom, or we can say that functional group within the molecule from one side to another side. So here CH3CO is transferred to ortho position as well as para position. So this is the example of rearrangement reaction. The same like example we will discuss in our next lecture is benzylic acid rearrangement. Benzylic acid rearrangement. So this is the example of rearrangement. So here we can see that there is a movement of this group from position 1 to another position, right? Now the next reaction is the photochemical reaction. Next reaction is the photochemical reaction. Now as we know that any photochemical reaction is performed using the photon. हम इसको H nu ऐसे दिखाते हैं, H nu. So here the reaction is carried out by using the photon, or we can say that UV light, or we can say that photoiridation. It is also known as photoiridation. Right? So photochemical reaction always performed by using the photon. Now the beauty of photochemical reaction is there is a minor transformation in the molecule. There is a minor transformation within the molecule. For example, let me take one example. Here COOH, here COOH, here H and here H. This is known as fumaric acid. It is known as fumaric acid. So now we know that here the position of two same group is in opposite side. Either we can take hydrogen or we can take acid, but we know that to designate this molecule as a cis or transform, at least one group to each carbon should be same. दोनों कार्बन के पास कोई एक ग्रुप सेम होना चाहिए. सपोज कि यहाँ पे हम Cl ले लेते हैं, यहाँ पे हम Br ले लेते हैं, तो एक डिफरेंट होगा तो चलेगा, लेकिन हर एक कार्बन के पास कोई एक ग्रुप सेम होना चाहिए. सो लेट मी टेक hydrogen as a standard one. So here the position of hydrogen in opposite direction, so we can say that this is the transfumaric acid. Now transfumaric acid, by applying photoiridation, by applying the photon, by applying the UV light, it is now converted to like this. So now here both the hydrogen is in on same side, so we can say that this is the cis form. So the simple case in the photochemical reaction is the transform is converted to cis form, or vice versa, or we can say that suppose we are starting with the cis form, right? Now iridation by using photon, so it converted to transform. So here cis to trans and trans to cis form is converted, right? The best example of photochemical reaction is the photosynthesis by the plant. Photosynthesis, as we know that the plant using the CO2 and water and sunlight. Here sunlight act as a photon. So here CO2 and H2, it gives glucose plus O2. So this is the best example of photochemical reaction, photosynthesis by the plant. Okay, next reaction is the oxidation reaction. As we know that in case of the oxidation reaction, there is a addition of in case of the oxidation reaction, there is a addition of oxygen, or we can say that removal of hydrogen. So in case of the oxidation reaction, either you can add oxygen or you can remove the hydrogen depending on the reaction condition, depending on the substrate molecule. Let me take one simple example. For example, benzene having the aldehyde as a functional group, so it is known as benzaldehyde. Benzaldehyde on oxidation using the KMnO4. Now as you know that KMnO4 is the strong oxidizing agent. It is strong oxidizing agent. So here aldehyde group. Now as per the definition, we have to add the oxygen. So here addition of one oxygen. So aldehyde, or we can say the benzaldehyde, is converted to benzoic acid. One hydrogen is addition of one hydrogen. So this is the example of oxidation reaction. Let me take one more example. For example, any alkyl group on oxidation using the strong oxidizing agent. You can use KMnO4, K2Cr, H2CrO4, which is known as chromic acid, HCrO4, chromic acid. So this is the strong oxidizing agent, right? So here CH3 is converted to CHO. So here both the phenomena occur at the same time, addition of oxygen as well as removal of hydrogen. Here we remove the 2 hydrogen, so here minus 2H, addition of 1 oxygen, so aldehyde group is formed, right? Now one more thing is that the aldehyde is not very stable. It is oxidized in the presence of O2 also. For example, if we take the benzaldehyde in one dish and keep for this some time, so benzaldehyde automatically absorb the oxygen molecule and it is converted to COOH. So we can say that there is no need to give heat or any photon, no need, because the aldehyde is oxidized using the atmospheric oxygen and it gives the COOH group, right? Now oxidation reaction and the vice versa reaction is the reduction reaction, right? So here addition of hydrogen, this is the totally reverse from the oxidation reaction. So here addition of hydrogen, or we can say that removal of oxygen. Right? Let me take one example. This is the example of a reduction reaction. For example, if we take the nitrobenzene, add Sn plus HCl, right? Sn plus HCl at 0 to 5 degrees Celsius temperature, and it is converted to aniline. Benzene having the NH2 as a functional group, NH2 as a substituent, is known as aniline. So nitrobenzene on reduction, it gives aniline. So here removal of oxygen as well as addition of hydrogen. So this is the example of reduction reaction, right? So our one topic type of reaction in organic chemistry is almost complete. Now this 7, so we have discussed the 7 type of reactions. So this 7 type of reaction we will use in our next classes, right? Okay, now the next topic is the arrow notation used in the organic chemistry. Most important, arrow notation. So I think 2 to 3 types of arrow you already discussed, already studied in your lower classes. Now there are many types of the arrow notation. Out of that, the first one is the forward arrow. First one is the forward arrow. We will discuss all type of the arrows by using some examples, right? So in case of the forward arrow, let me take the same example which we have discussed in the oxidation reaction. For example, aldehyde on oxidation, it gives COOH group. So this arrow is used to give, or we can say that to showcase the direction of the reaction. So here we can say that here this reactant is converted to this product. So this arrow showcases that one atom or one group or one molecule is converted to another one. So this shows the direction of the reaction. So this is the forward arrow, reactant converted to product. Same like we can also discuss here the reverse arrow. For example, acid is converted to aldehyde. So this is the reverse arrow. So we can say this is forward direction, this is the reverse direction, right? Is it so? So here forward arrow shows some direction of the reaction. Now the second one is the equilibrium arrow. हमने ऑलरेडी देख लिया होगा, कब कहीं ना कहीं पे आया होगा इक्विलिब्रियम. फॉर एग्जांपल इफ यू टेक वन एसिड, सो बाय एडिंग दी वाटर, हम इसको बोलते हैं एक्वस सॉल्यूशन. जब किसी मोलेक्यूल में हम वाटर डालते हैं तो हम उसको बोलते हैं एक्वस सॉल्यूशन. इफ योर रिएक्टेंट इज इन डिसॉल्व इन दी वाटर, देन वी कैन से दैट इट इज एक्वस सॉल्यूशन. सो acid on react with the water. So first it gives the COO minus plus H3O plus. Now as we know that this is the forward arrow. Now one more arrow we use like this, half and half, not full arrow. This is forward arrow. If both side is this type of arrow, then it is forward arrow, but here half and here half. This is the equilibrium arrow. Now this arrow showcases that this reactant converted to this, and at the same time these ions are also combined back and give acid plus water. So this is known as equilibrium arrow. In case of the equilibrium, we can say that the rate of forward direction is same as of the reverse direction, or we can say that the backward reaction. Rate of forward reaction and rate of backward reaction is same in case of the equilibrium reaction. And to show the equilibrium reaction, we use equilibrium arrows. That means reactant to product, product to reactant, conversion rate is same, right? Rate is same. Is it okay? Now the third one is the resonance arrow. हमने बहुत बार देखा है resonance arrow.